Hey students, welcome to class. We have arrived at day 4 of our exponent property review unit, and today we're going to be looking at what are called rational exponents. Well, I thought it might be a good thing to start with what a definition of a rational number is. And in mathematics, a rational number is any number that can be expressed as the quotient or fraction of two integers with the denominator not being equal to 0. So when we're talking about rational exponents, we actually are referring to an exponent that can be written as a fraction or a quotient. So a rational exponent is an exponent that can be expressed as m over n, where m and n are both integers and n cannot equal 0. So in other words, the denominator cannot be 0. Radical expressions can be written using rational exponents. So let's take a look at our property box here, rational exponents, and for any natural numbers, this is going to hold. For any natural numbers n and m, in other words, natural numbers being like your numbers that you naturally count with, your counting numbers, 1, 2, 3, 4, 5, 6, 7, 8. So m and n can be any of those natural numbers, those counting numbers. So the exponent 1 over n indicates to take the nth root. So when we talk about taking roots, that means we're seeing, like if for instance, I'm taking a square root, I'm looking for a number that when multiplied by itself 2 times will actually give me the number, which is actually called the radicand, which is the number under the radical sign. So if I raise something like 16 to the 1/4 power, what that really means is I'm taking the 4th root. And so if I said take the square root, that would be saying it the same as raising something to the 1/2 power. Okay. So an exponent of 1 over some natural number actually commands you to take a root. So if we combine and have a fraction where the numerator is not 1, and we have some other natural number as the numerator, and in general, we have an exponent of the form like this, m over n, then the m actually represents a power. So the numerator actually, numerator equals a power, and the denominator says to take a root. So a rational exponent is actually a combination of both raising a base to a power and also taking a root of it. And so a really easy way to remember which one is a power and which is the root, when you think about a fraction, we have a top and a bottom. And remember that roots, they grow underground. So if you look on the bottom, as if like the fraction bar is the ground, then the roots grow underneath. And when we think about power, we sometimes say a higher power. So the power is on the top. So whatever number is on the top of that rational exponent indicates the power that you want to raise the base to, and the denominator tells you what root you should take. So when we're actually writing in math, when we talk about this denominator, the denominator of a rational exponent actually becomes the index of the radical. So for instance, a square root, the index is actually a 2. We're taking the 2nd root. Or a 3rd root, something like this, that would actually be associated with a rational exponent that has a 3 on the bottom. Now when we apply rational exponents to different bases, there really is 2 ways to approach that, because that rational exponent indicates 2 commands, both raise to a power and take a root. The order that we actually do those in really doesn't matter, but in most cases doing one of those first is usually easier, and it's the one that's where you're taking the root. So let's say I ask you to raise negative 32 in parentheses to the 3/5 power. What that really means is that negative 32 is the base, and that I want to raise it to the 3rd power, and I also want to take the 5th root. Now, I'll show you 2 different methods. The first method, I'm actually going to take the 5th root first. So I know that that 5, that denominator becomes the radical index right here. I've got the fifth root. And when I think about some different fifth roots, I know that 32 actually is 2 raised to the 5th power. So it's kind of a common one. Once you spend a little time talking about exponents, you'll hopefully have a pretty good repertoire of different perfect, like squares or cubes or whatever. So when we take the 5th root of negative 32, we actually get negative 2. Well, then now what's left to do is actually raise to the power. And so I can take that negative 2, multiply it by itself 3 times, and I get negative 8. Now, doing it the other method, I could go ahead and take negative 32 and raise it to the 3rd power. So I'm going to pause the video real quick to go to my calculator. And when I raised negative 32 to the 3rd power, I actually got negative 32,768. And now I could go to my calculator and take the 5th root of that. But notice that is a really large number, and it's not going to be one that I probably have memorized. And so I actually have to go to my calculator, and I'll kind of hopefully remember to show you before you actually are watching this video how to use your calculator to do roots other than square roots or cube roots. But you can go under the math menu in your graphing calculator, and you'll actually see that there's a key that looks like this. It's got an X out in front. So if you put the number 5 in, then go to the math menu and then select this, that'll bring up so that it says a 5th root, and then you can put in the negative 32,768. I did that on my calculator and I got negative 8. Didn't it seem like the first method was much less complicated? And we got the same answer, and that's because I went ahead and took the root first. So taking a root is actually giving you a smaller number because we're looking for the number that can be multiplied 5 times to get negative 32, which is quite a small number, negative 2. And then we're raising then a very small number to the 3rd power. Rather than the other method, when we took the power first, we were raising negative 32 to the 3rd power, and then we were having to turn back around and take the 5th root of that number, which is not a number that's very common to us. So in this case, it was much easier to take the root first, and that usually is the case. Let's flip to the next page. Okay, so I noticed that there's actually a typo on this question. This question is supposed to say 64 to the 2/3 power, so we're going to go ahead and fix that up. It's going to say 64 raised to the 2/3, not the 1/3 power. And so I'm going to show those 2 methods again on how to do that. But I'd actually like to have, I'm going to pause, and I'm going to have you pick one or the other to try first. I'm going to do both, and then you can turn the video back on and check your answer, and hopefully you picked the way that was easiest for you. So I'm hoping that you chose to do it the method 1. And this is the way, like I said, in almost every case that I will proceed. I will always take the root first because it gets a much smaller number. And in this case, I took the cube root of 64 because I knew that 4 times 4 is 16 times another 4 is 64. So I knew the cube root of 64 was 4. And then I took 4 and applied the power, again, which came from the top of that rational exponent. Oops. And I applied that power of 2 to it to get a final answer of 16 then. Now here's another example for you to try, and I'd actually like this to be a you try, and it's a you try I'm not going to give you the answer to until you come into class. A you try question or a YTQ. So I'm going to be looking for that in class next time to make sure that you tried those independently. And so if you want to stop the video now and try it, or you want to go back after the lesson is complete and try those, but I would like you to try, and you can actually choose which method you'd like to do. You don't have to show it both ways, and in the case of our practice sets we do in class, you never have to go both methods. Just pick the way that works best for you, and just choose to do one method. Now, a second skill we want to be able to have by the time we're done with this lesson is to actually be able to go in the reverse direction. So in other words, if something's written in what's called radical form, we want to write it using rational exponents. So in example 2a, our goal is to write expressions by using rational exponents. And so the first thing we always want to be able to do is identify what is the base. So in this case, the base is 13. So what's the power? When we think about the power, it's going to be a fraction. And we said that the power is on top, so higher power. And the power here that the base is being raised to is the fourth. And the root, which they grow underground, so in other words, the root that we're taking is the 8, so that goes on the bottom. Well, it turns out that 4/8, which is what that exponent is, can be reduced. And it can be reduced to 1/2. So in the event that we could reduce our rational exponent, we do want to do that. So what does really 13 to the 1/2 power mean? Well, what that means is raise 13 to the first, which of course is not going to do anything to 13. Raising something to the first power really just keeps that number itself. But then the bottom, remember, means take the root. So what this really means is the same thing as taking the square root of 13, which we really can't simplify because it's not a perfect square. So we're just not going to worry about that. We're just going to leave it the way it is as 13 to the 1/2 power. So that would be our final answer. So take a moment, pause the video, and try example B. Okay, so for example B, I was able to rewrite using rational exponents the expression as 13 to the 15/5 power. Because the power was 15 and the root was 5, but 15/5 actually reduces to a whole number of 3. So this really is actually a whole number exponent. And so when we raise 13 to the third power, it's not too big of a number, and so we want to go ahead and actually find the final value or evaluate that. So 13 to the third power would be 2,196. So what I'd like you to go ahead and do is try example 2b and all 3 parts as a you try example. And again, I'm going to check these tomorrow in class. So I'm going to leave you hanging for just a little bit. So I want you to give them a try. And tomorrow, or I'm sorry, whenever we meet in class next, it may be. Maybe this is Friday, I don't know. But anyway, next time we meet in class, I will reveal those answers to you, and you can check to see how you did. And if you have any further questions on anything in the lesson, be sure to make note as on your WISC sheet as well. So I'm going to see you next time in class.